Let's take a look at the process for finding coterminal angles when the angle is expressed in radians. Suppose we have theta equals 3 pi over 7. If this is in terms of radians, I could add the label radians, but radians actually serves as a default angle measure. So if you see an angle measure that doesn't have a degree next to it, the assumption is that it is an angle expressed in radians. So how could we find an angle that's coterminal to theta? As with angles in degrees, coterminal means that the terminal side ends up in the same place, and so we get coterminal angles by adding or subtracting full rotations. In radians, a full rotation is 2 pi radians. And so a coterminal angle would come from taking 3 pi over 7, for example, and adding 2 pi. But to add those together, I need to think of 2 pi as a fraction, so I could think of it as 2 pi over 1, and then to set up a common denominator, I can multiply both the top and the bottom by 7, and so we get 3 pi over 7 plus 14 pi over 7, and so a coterminal angle, there are many, but one of the coterminal angles to 3 pi over 7 is 17 pi over 7. We could find a negative coterminal angle by doing a similar calculation but subtracting. So I could take 3 pi over 7 and subtract 14 pi over 7. And so a negative coterminal angle would be 11 pi over 7. A similar process can be applied to supplements and complements as well. For supplementary angles, I can think of two angles as being supplementary in terms of radians if their measure adds up to pi radians, because pi is equivalent to 180 degrees, so it relates to a straight line. So for our specific example here, 3 pi over 7, if I add some angle to that, I want it to equal pi. Of course, we can think of that calculation as equivalent to y equals pi minus 3 pi over 7. And so we can create common fractions by turning the pi into 7 pi over 7. And we see that the supplementary angle is 4 pi over 7. In a similar way, with complements, two angles are complementary if their radian measure adds up to pi over 2. So looking at our example, if I have 3 pi over 7, I want some angle y that I can add to that to get pi over 2. So likewise, that's the same as thinking of y as being equal to pi over 2 minus 3 pi over 7. And so again, we need a common denominator. This time, I need to multiply the second fraction by 2 and the first fraction by 7. And the common denominator will be 14. So I get 7 pi over 14 minus 6 pi over 14. And so the complement to 3 pi over 7 turns out to be pi over 14 radians. So let me end with the following question. Find the supplement, complement, and at least one coterminal angle for the angle beta equals 4 pi over 15, and we mean by that 4 pi over 15 radians. I encourage you to take a few minutes, think about that. I hope you enjoyed the video. Thanks for watching.